back one slide. Okay, thanks for everyone's patience here. Yeah, these are the COVID webinar technical glitches that you have from time to time. So starting off here, we're going to go over our XW Pro solution. And this right here is a look at our XW Pro plus all of the accessories. The XW Pro is designed to work in both DC coupled applications and AC coupled applications. DC coupled applications use a charge controller. AC coupled applications, we work with, say, SMA inverters, in-phase inverters. If you look on the left upper corner, you see our charge controller product line. We have an MPPT 60 that's 150 volts open circuit. We have an 80 amp charge controller that's 600 volts, so like a traditional string inverter. And this fall, we're going to be launching a 100 amp charge controller, so another 20 amps, which is roughly a 6 kilowatt PV array. On the monitoring side, we have a new Gateway product, and this allows us to do remote monitoring, remote control. It also allows us to do Modbus and CAN bus integration with different third-party products, battery BMSs. It also is used to meet certification requirements for like the phase 2 and phase 3 of Rule 21. We recommend it connects Gateway with every XW Pro. Connect Insight is our cloud-based portal. Really, really cool. Basically takes all the data, allows you to look at it through the cloud. The Connect Battery Monitor is a state of charge battery monitor that our XW can make decisions based on. This is really important with lithium ion batteries, so I'll talk about that a little bit later. The Connect Disconnect RS is how we meet NEC requirements for rapid shutdown, and that's used in conjunction with our charge controllers. The Connect Config tool is for configuration commissioning, really comes into play when you have stack systems, you have multi-inverter systems. AGS, we work really well with generators. It's a core part of our application, so this allows you to do an automatic gen start. And then finally, we have UL listed distribution panels, wiring boxes for both your AC and DC connections. Okay, next slide. Okay, as you can see, this product line is good for a whole host of applications in the 6 kilowatt to 40 kilowatt size range eventually once we do 3-phase and even 60 kilowatts. The big thing is this product line has been, variations of this have been around for about 15 years. And this product line was built around off-grid systems, where it was really important to have the most rugged, durable, reliable product out there. And that was our goal when we designed this platform. We work really well with generators. We work really well when you're starting inductive loads. One of the things I will point out is this says residential grid tie with critical load backup. What that means is this product also, when you switch, when you're in a grid tie situation and you lose utility power, it's a seamless transfer to battery power. So your lights are not going to blink, and your computer loads, those critical loads, are not going to turn off. They're not going to notice anything happen. Next slide. Okay, as you can see here, there's been 3 different iterations of the XW product line, the newest being the XW Pro. We have hundreds of megawatts of XW units installed over the last 15 years. So it's a very reliable, durable platform. As I mentioned, it's been tested and it has worked very, very well. The XW Pro, the latest iteration, was developed to meet the new advanced grid requirements. So I'll go into that a little bit later. Also, really enhancing our capabilities with lithium ion batteries, which is really fast becoming the standard battery used for these types of systems. We've done some things to enhance our AC coupling capability, so I'll talk about that a little bit later. And then finally, really working on a modern day advanced communication monitoring platform with our Gateway and Insight 2. Okay, next slide. So this is a slide, this is just a standard spec sheet of the XW Pro inverter. I won't touch on this too much, but just to point out a couple of things. So this is a 6.8 kilowatt inverter, at 25 degrees Celsius. However, it's a really robust product for starting big motor loads. So we can actually surge for 60 seconds to up to 12 kilowatts. So if you're starting an air conditioner or an inductive motor, the product is going to work. It's not going to fail when that application happens. In addition, we run 8.5 kilowatts for 30 minutes. Okay, next slide. So this is kind of a line diagram of our architecture. The one thing I'll point out is you see AC1 and AC2. AC2 is our generator input. And what this means is we can really connect and synchronize with most any generator. So working with generators is a key part of our application, and we work very well with them. Next slide. So the XW inverter, it's really designed where backup power is a premium, where you want to work well with off the grid. We can stack multiple inverters, 4 inverters in single phase / split phase, and we will be able to do 9 inverters 3 phase sometime later this year. The product's easy to install, and we'll get into some of the smart energy management controls and lithium ion battery compatibility. We'll save that for the end. Go to the next one. Okay, what's new with the XW Pro versus the XW Plus? So the biggest thing, one of the biggest things is lithium ion battery compatibility. So what we do traditionally with lead acid batteries, you really made your decisions based on voltage. And now what we do is we can do that with state of charge with our battery monitor. And I'll talk about that a little bit when we get into the lithium ion battery section of this presentation. We have communication, BMS communication with lithium ion batteries through our Schneider Gateway for closed loop communication. AC coupling, what we have done here is we have sped up how quickly our frequency shift acts. So basically not to hit the batteries with such a high current. So there's not any issues there. Self-consumption, we have a meter now that allows you to sell back to the main panel and not sell to the grid in places where it's not allowed. And finally, we meet some of the latest grid codes, which is frequency watt volt bar, frequency and ride-through voltage. So these are the big parts of Rule 21, which is UL 1741 SA. In addition, we're really excited to say we meet phase 2 and phase 3 of the requirements in California, which will be standards everywhere in the US at some point. We have HECO certification, which is for Hawaii. We have PREPA certification, which is for Puerto Rico. And then we also do IEEE 2030.5, which is a protocol for utility command control. This is required for UL 1741 SA, and it's kind of ties into the final category, which is the utility and BPP protocols. And I call that the wild, wild west of the utility command control that we're kind of in right now. Okay, next slide. So ultimate backup and performance. So the product, the XW Pro has a dual input for grid and generator. So again, that allows us to be compatible with almost any generator. We can synchronize when the generator is running, it powers the loads and charges the batteries at the same time. And generator power is typically outside of what your grid power would be. So that allows us to widen those input windows so we can work with those generators. The overload power rating, as I mentioned, it's 8,500 watts for 30 minutes, 12 kilowatts for 60 seconds. The product is really designed to work well in high heat situations. So we're 6.8 kilowatts at 25 degrees C. The XW Pro derates to 6 kilowatts at 40 degrees C, but it's going to continue operating all the way up to 70 degrees Celsius. So you'd be hard pressed. If there's anyone here from Arizona on the line, they might say you could get to 70 degrees C after this last week, but in most places, you're never going to approach any temperatures like that. The 8 millisecond transfer time, That is UPS grade transfer capability. And finally, we have a 140 amp charger, which is a really large charger, so you can charge your batteries quicker. Next slide. Scalable and flexible solutions. So the XW Pro out of the box is 120/240 volt solution, so you don't need an external transformer to get 120/240 output. We can stack 4 units in parallel in that configuration. Later this year, what we're going to have is we're going to have 3-phase capability, which is 122/08. So you convert the units to 120 volts, put 1 inverter per phase, or if it's not up to 9 inverters, that would be 3 inverters per leg. DC coupled or AC coupled systems, as we talked about, lithium ion batteries for closed and open loop. And finally, yeah, this is for grid tie and off-grid systems. Next slide. Easy to install. All of the accessories communicate seamlessly with one another through our ZAN bus network. The connection is a Cat5 cable between each one of the devices, which makes for a very easy setup and seamless integration. Next slide. Smart management. So if you're in an area that has time of use rates, or you're looking to do peak shaving, you can program the XW Pro to do that. Certain places have high demand charges, so you get charged if you go over a certain kilowatt usage. And what we can do is we can inject battery power to offset the power from the grid, so you don't hit those peak demand charges. Self-consumption is becoming much more of a high priority in places where you're really not allowed to sell power back to the grid, or you're not allowed to net meter. And that's using our battery monitor even enhances that further, so you can basically sell power back to your main panel and not export to the grid. Next slide. The Connect Gateway. This is a really exciting product for us. It allows us to do remote command and control, or monitoring and control. So if you want to change settings remotely, you want to start your generator at your remote cabin, you can do that. You can do that through the cloud. It's very, very simple to do, simple to set up. This also, as I mentioned earlier, this has both CAN bus and Modbus inputs, so we can connect with third-party devices that use those protocols. There's also going to be a lot of things for aggregating systems. And finally, the biggest thing as well is that this allows us to meet the California standards which are going to be required everywhere in the country. Next slide. Insight 2 is, again, I mentioned earlier, this is the new cloud-based monitoring platform. Runs on top of with the Connect Gateway. And there's also a lot of things you can do with aggregation, multi-site monitoring with this solution. Very, very cool. There's a phone app that we have as well that allows you to look at your system over a phone app with real-time information. Next slide. Okay, this is the meter that we use that allows you, it's basically a CT-based meter that you put at the main panel, and makes it so you don't export to the grid. This is a hard requirement in Hawaii. What happens a lot of times is people want to put their bigger loads at the main panel. They don't want to back those up with battery, but they want to offset those loads. So you can put this at the main panel, and it will let you know, it will prevent you from exporting to the grid. Very good for self-consumption systems. We're seeing this in a lot of places as well. A lot of people in California like to have this meter. And this is going to be more and more common throughout the United States. Currently, we do not sell this meter. But we are hoping to add it to our list of products sometime in the next few months. The next slide. Okay, starting to run a little short on time, so why don't we skip this slide? Let's go to the lithium ion battery section. Keep on going. Next slide.
It's taking a little bit of time to switch slides.
Okay.
For some reason it's lagging.
Okay. We're seeing DC coupled and AC coupled systems here. Lithium ion battery capability. So
That's good.
yeah, this slide's perfect. So lithium ion batteries are a little different than lead acid batteries. Thermal protection is important. So it really is important for us to have control of those batteries in some way. Traditionally, what we have done is used open loop communication, which means we take measurements and we can see things like voltage. Our battery monitor is really cool because it gives us battery state of charge. And I'll show you in a second why this is important with lithium ion batteries. We can actually make decisions based on battery state of charge. So if you're using us in an open loop situation, then what you would use is you would use our XW product and you would use our Connect battery monitor. And this is what we've traditionally done with Fortress, is using this type of configuration. Now what we're working on though is going more advanced than that, where the battery BMS is actually communicating with us. So we are able to make decisions based on what that battery management system is telling us. So temperature, state of charge, we can make decisions based on that. And I like to think of this as like, hey, we've got a Ferrari as a battery here, and now we know exactly how much fuel is left in the fuel tank, and we know exactly the condition of that battery, which we've never had before. If it's an open loop situation, you really need to have the battery monitor. I'll go to the next slide, please. Keep on going, one more slide. Okay. Next slide, there's something. As you can see here, in the past, we used to make decisions based on voltage. And that worked very well with lead acid batteries because it was a pretty linear reduction in voltage to give you pretty much where the capacity of that battery is. With lithium ion batteries, it's very, very different. If based on voltage, it's really hard to tell if that battery is at 90% capacity or 30% capacity. So our battery monitor gives us true battery state of charge, so you can really tell what the state of charge is of that battery. Can we go back 3 slides? Okay, this is good. So we're really excited to be working with Fortress on a closed loop battery integration. This is kind of the future of battery management and working with our system. It basically allows you to run your batteries deeper, more efficiently, and it also prevents the batteries from tripping, because of reactions from the BMS, because the BMS is telling us these are the conditions of the battery, this is what you need to do from a charging perspective. It also makes it a lot easier to work with those batteries AC coupled. Eric is going to go into some more detail about the closed loop battery integration. And I'm looking at our time. I think we're about time. So Jamie, I would like to thank everybody for listening to our presentation today. And I'm going to pass this over to Eric and let him really talk about some of the integration on the BMS side.
Okay, before we get to Eric, we're going to take a quick poll.
Okay.
So if everybody can participate, I'm going to set it up right now. So launching. Launch. Let me know if you can see it.
Yes, we can see it.
Okay. Okay, so if you guys can answer, all right. We have 86% saying 0 to 5 per month. About 7% 5 to 15, and about 5% 15 plus. So just so you would know, this is out of 250 participants.
Okay.
All right. Okay. And
All right.
Eric, go ahead.
Yes. Are you gonna fly the slide off for us, or you want me to take over control?
No, I will do it.
Okay. So hello everybody on the webinar. So my name is Eric. I'm a Chief Technology Officer at Fortress Power. 16 years experience in the automotive manufacturer and the energy sector. So we're going to talk about a few topics today. First, Jack's presentation. Here we talk about on the Schneider equipment side. I will go a little bit more in depth on the battery side. So we'll talk about our company very quickly, and then we'll talk about why do we use a lithium battery. And then in this sector, we'll also talk about the different chemistry of the lithium batteries. I will spend a good amount of time to talk about our product, particularly the product we hook up a closed loop communication with Schneider. That's the new product we have, eFlex. And then in the last sector, I'll go a little bit in depth, just how to set up the closed loop communication, and then what's the advantage of it. Second slide, please. So Fortress Power, we're one of the few lithium battery manufacturer bring the lithium ion phosphate chemistry from the automotive industry to the energy storage industry in the USA. Our headquarters is in the US, Southampton, PA, close to, it's like 40 minutes from Philadelphia, an hour and a half from New York City. We have a 30,000 square feet facility for the R&D, testing, sales, and logistics. We do have a separate logistics center in California and Florida to support the different market demand. Over the past few years, we've been installed over 70 megawatt worldwide. And then we are also the dedicated battery partner for the local railway system. So we help them to design and then install the backup system for their traffic light and then traffic system, which has highest requirement. If you have a similar requirement or customer, please contact us. We do have expertise on that. Next slide, please. Why lithium? So why do we choose the lithium battery? That's a big question. And Jamie, go second slide. So lithium battery versus the traditional lead acid or the AGM or improved lead acid batteries are much better just in every single way. So it's a low energy cost in long run, it's long lifespan, high efficiency, and the weight is only about 1/3 of a traditional system. No maintenance, no ventilation, and then you can do 100% depth of discharge. And it also supports a fast charge and discharge function too. And then during the discharge cycles, most of the time you see on the lead acid, you lose power a little bit. And then at the end of a discharge curve, you see the power lose quite a bit because the voltage drops. So in the lithium battery, particularly lithium phosphate, so our curve is super flat. So you will get a consistent, if it is 5 kW, you will get a 5 kW from beginning to the end, a consistent power output to the system. Next slide. And then here we come down to a little bit details on the number. We're trying to quantify what we tell our customer and the installer. So on the round trip efficiency, the lithium phosphate, the battery were at 90% or above. So traditional system, you look at the maximum 88%, most of them stay at 80% or 75%. The life cycle of at 80% of the type of discharge is 6,000 cycles, slightly lower than the nickel iron. However, the cost is much cheaper than that, but it's much better than the AGM or flooded lead acid. So which makes the off-grid year can go up to 16.4 years. The total energy output will be 47 megawatts through their life cycles. The way we calculate is very It's very practical because we use the nominal capacity time 80% of that discharge. So plus then multiply with the efficiency of it. So you will see nickel iron come close to what we gave to them. However, the cost is another factor for the nickel iron batteries. Usually nickel iron battery is used on the hybrid car because of longevity and then the cycles. And come down to the cost per kilowatt hours, the lithium phosphate battery is at 14 cents per kilowatt hours, and all the other batteries are much higher than that. And then regarding the safeties, so lithium phosphate is very, very safe. Right? We don't have any issue. You don't have to go back to maintenance. And the flat acid, if you don't do the maintenance, you have good chance to short the batteries. And the maintenance is another big factor. In the traditional system, you need to get a ventilation system. You have to have people go back and then do the maintenance for the battery stack, which lithium battery, you don't need it. Next slide, please. So lithium battery is just new technology. If you are working in the energy storage sector, so that's no-brainer. That's the way to go. So the traditional system is just not good enough to handle the demand of most of the homeowner and the customer as a backup time of use purpose. And just the lithium battery's cost is driven by the automotive. So it costs come to be very cost effective for the homeowner. Market is widely accepted. But I didn't mean that's just you have to use lithium for everything. If you still have a like motor starter or something, those things. So lead acid is still cheap enough to do that function. Here, what I want to focus on is only on the energy storage side. So in the lithium battery, we have a different chemistry. So the Fortress Power, we're using lithium ion phosphate chemistry, which has been improved, has a super safety and then high performance. The longevity is better than anybody else, and then the cost of energy per kilowatt hour is cheaper. So here, my comparison is lithium iron phosphate compared to the lithium ion. Lithium ion here, I mean typically is NMC or NCA, so which is the lithium nickel cobalt manganese oxide or the lithium nickel cobalt aluminum oxide. So those chemistry has high energy density. However, their safety is the biggest concern for most of people. Lithium polymer, so in every way, is not good enough to be the energy storage chemistry in the lithium battery business. So the way we choose this lithium phosphate has been tested, and then we found out it's the best chemistry for the energy storage. It's much tolerable for the charge and the discharge. It's much tolerable for the temperature as well. Next slide, please, Jeremy. So here's the simple test between the lithium iron phosphate and then NMC cell. So that's the penetration test. You see on the left side, you see slightly smoke come out, but there's no fire come out. So NMC, as long as it start penetrate the whole system, it start catching the fire. So although it has a high energy density, got a very popular in the home car or automotive industry. However, in the energy storage sector, we don't worry about too much space. So we're already much smaller than the traditional lead acid. So that's one of the decision factor for us to choose the lithium ion phosphate. Next slide, please. So then we talk about our product, Fortress Power product. So we currently carry 4 products in our catalog. So eVolt, eFlex, LLP10, LLP5. So they're differentiated from the BMS technology and also the capacity. The first 2, eVolt and eFlex, you see that is a contactor-based embedded computer BMS system. So it's designed to handle high power output and input. The differences in between is eVolt has higher capacity, eFlex has lower capacity, designed for the multiple different industry. I will put a little bit more focused details on the eFlex later. And the LLP10 and 5, so is designed for reliability, and then we've designed that for a typically smaller system. Next slide, please. So here is to give you a little bit more visual feeling of it. So Fortress Power, from day one, we start engineering product. We deeply embedded the continuous improvement concepts. So on the LP 5 and 10, we designed the system robust enough to handle most of the inverters and to be compatible with most of the inverter and handle most of the different situations. And then in the eVolt, we integrate the live monitoring, and then also we make the BMS smarter, which can stack up to 12 units in the system. And this system is designed really for high power output and input, like what Schneider just mentioned. So their equipment can surge up to 12 kW for 30 seconds, 8 kW for 30 minutes. So this battery handles it no problem. And eFlex, which I want to put a bit more focus on it. So that's we design the system more smarter, more flexible. So we'll talk about the details in the second slide. Next slide, please. So eFlex is just way better in her, to compare to whatever we see in the market from our competitor from 3 perspectives. It's getting smarter, it's getting the latest pack technology, and then we design the things is for flexibilities. Smarter, so we have a high power embedded computer system. So it's able to do multiple different communication protocol, even the complicated one like CAN, Modbus, MQTT. We have the Wi-Fi chip embedded already to be able to IoT ready. And then the system also take a good amount of data from our battery cell, and the modeling in it, it has a dynamic charge and discharge control, which we'll talk about later. That's how they communicate with the Schneider system and tell the inverter what to do, what not to do. And then the computer system is also able to monitor each individual cell in this system. We are IoT ready, so the Wi-Fi chip and the Bluetooth has been embedded in the system. So in the future, we're gonna have the battery connect to the cloud service, and then we'll monitor the system for the customer. If you're an installer, if we see the potential failures in the field, we'll tell you already before it happens. If you are the homeowner, we'll give a pre-warning by email, tell you, so what's your system situation? Should you change some parameter or not? So this function will be available in the Q4 this year. And then in terms of a pack technology, so in this pack architecture design, we use the latest technology, which they call the cell-to-pack. This one has multiple advantage. So from the architecture design and enclosure design, so we basically improve the thermal performance 5 times, which enable us to charge and discharge the battery faster. Most of the battery will use up to 2 hours to charge it up. So in the special situation, you can take only 45 minutes to charge up the batteries. And then our enclosure is IP65 rated, and then you can install outdoor without a problem. If you set up a communication with a Schneider, so the system will optimize everything for you. It's give you peace of mind. So overcharge or discharge at high temperature will damage your battery a lot of time. In this case, it will never happen. So on the flexibility side, we primarily designed this product to be in the home energy storage business. That's the primary business we have. But we also have the idea in mind we can use on the RV application. If you have a RV, want to hook up the 48-volt system to supply the power to your appliances in RV, and also the telecommunication and the server power backup. So in the server center now goes into the decentralized power backup system. You used to have the lead acid in the big battery room to back up whole system. Now you can decentralize, have each individual battery pack and sit right next to the server and hook up a UPS system. You just supply the backup power to the server rack. And in terms of the installation, so the system, we can do the wall mounting. We provide the wall mount bracket. As you see the picture from left to right, the third one. And you can also put in the standard 24 inches server rack, which we see the last picture on the bottom. And the system is perfect fine if you want to sit on the floor. We do provide a kit that you can stabilize the battery pack on the floor. And the system is smart enough, also you can step up Just in any delivery, you can stack up to 15 units. If you have a special requirement, we can make it a more stackable up to 50 piece unit, but that's per customer special order. Next slide, please. Okay, then we talk about the main focus of today is the closed loop communication. There is a countless advantage if you have closed loop communication. Here, I only want to point out the three, which is most important, and then important for you and for your customer. So in this system, we typically see you improve 5% efficiency. So in the open loop communication, we always use voltage to control strategy. So sometimes it depends on your load in the system and your charge and discharge rate. We're basically shooting on a little bit of a moving target. With BMS SOC control, so we can improve 5% of efficiency of used lithium batteries. Second, the accuracy. So BMS control the charge and discharge curve. So we're all familiar with a 3-stage, 2-stage charge and discharge. Is that the best for lithium battery? That's not necessary. So it always depends on temperature, load, and charge and discharge rate. In this way, the BMS really understands what's happening in the battery on each individual cell levels. And then you control the charge curve up and down, try to accommodate to the best scenario. So you still go with the stage philosophy. However, so this is much more accurate. You will be able to fully utilize the capacity of the lithium batteries. And then the BMS system has the battery cell chemical and the electrical characteristic mode already in it. It's self-checking for multiple factors to prevent failures. And then there's always dynamic interaction between the eFlex battery with the inverter. So make it a great ecosystem when you use the battery system. And for the end customer, it's definitely improved customer experience. So the system basically plug and play. You set up a few parameters and then you walk away, instead of go through everything like before. And you can also see your system remotely through the Schneider Gateway to see the percentage of SOC and what's the current status, temperature in the battery. So we provide most of the information through the BMS to the gateway. Next slide, please. Okay, now I go a little bit more in depth. Understand the equipment. I don't want to talk about the inverter or the other things because Jack already gave a much more detailed presentation on it. So here is the battery. So battery positive, negative terminal, everybody knows. We have a few lights shows indicate the status, and there's a front button on and off switch. Most important is we have a 2 communication port. That's where you use that to communicate with the Schneider context gateway, and the gateway will coordinate the equipment in the system of Schneider, and then just create the seamless customer experience. Next slide, please. I come down to a little bit details. I want to tell people, so it's not very complicated. It's not as easy as probably electric people are familiar with, but it's not as complicated as you have to build up your own computer system. So we provide all the equipment for you from the battery pack. When you open up the pack, you will see from the left, the first one, so IP65 bus terminator we provided. And then the communication cable between each battery pack we provided. And then we also gave you RG45 converter we provided. The only thing you need to prepare is one actual standard RG45 cable. And we have a clear layout of our pinout. The way you communicate with the Schneider system on the RS45 is pinout 7 and 8. It depends what standard you use. Color might be different, but it's always 7 and 8, those last 2 wires. So you can strip it off and then connect to the Schneider Gateway. Then go into the gateway to set up the system, which I have a second slide that shows a little bit of the interface of it. Jimmy, next slide. Yeah, here is the interface. So I don't want to go very much in depth. So what I can tell you is we and Schneider are working closely on the testing. Everything has been done. And the idea is we want to build the Fortress Power eFlex battery name into the drop-down list. And you can select the name of the battery and then the quantity of it. So the system will set up all the other numbers you see here automatically. But I do want to point out that it's customizable too. It's not something we preset, you can't do it. And then you can still go into the grid support mode to set up your SOC, right? I want to do 90% support grid or 180%. So there's more precise control. In terms of the control system, you always want to look at the lithium type. The battery type is lithium battery. And then charge cycle, instead of 2-stage or 3-stage, you want to select to the external BMS control. That means Fortress Power eFlex will take over the control of the charge circuit. Okay, next slide, please. That's pretty much what I want to talk about today in the limited time. So the new product has a lot of more features. And then our eVolt, we're also working on upgrading their computer system to be able to communicate with Schneider as well, and multiple other inverter company. So we'll definitely go on the more smarter and the more IoT concept in our product portfolio. And then the eFlex is already ready now. If you have a demand and you have a project lineup, please contact us. Here's our emails. And then if you have a technical question, always email us to the technical support. We can answer battery questions as well as some of the inverter questions. Just let us know if you need any support. Jeremy, I will turn back to you.
Okay, great. I'm going to go into some of these questions. We got quite a lot of questions for both Jack and for Eric. Let me start with this one here for Eric. When you stack vertically in a panel, does it need panel ventilation, particularly on the top batteries, which could pick up heat from below?
So can you say it again? So I stacked it up vertically.
Yes.
The answer is no. If you hook up communication, you don't need to. And then if you don't hook up communication, usually you don't have to. If you set up a system correctly, you don't need a ventilation system. We already have the heat sink, right, pre-built into our enclosure. So the thermal performance is 5 times better than ours. You just need to keep your rack certainly open. So you don't want to fully enclose the enclosure. You want to do a little bit like the air can come in and out naturally. So that will help the system.
Okay. Jack, this one is for you. It's from Philip. What is the guaranteed waveform stability under varying loads for the XW Pro?
The varying waveform is, so I think the question is, how much is the voltage going to change if the inverter is hit with a high inductive load? It's plus or minus 2%.
Okay. This one is from Joseph. Does the system play well off-grid with AC coupling and LiFePO for batteries?
If the system needs to be sized correctly, having a big enough battery bank and really having the PV size to the array, but you have to take some special considerations there because there is no place for excess power to go without a grid. So you really need to size it correctly, but yes, it is possible.
Okay,
right.
Eric,
just one comment. So the in the off-grid system, if you set up correctly, so the lithium shows much better performance because the lithium takes much more power than the lead acid. In the lead acid world, so you always have to use the frequency shifting to regulate the PV production. But in our situation, basically battery will take more power than you think, and then it helps the system just work smoothly.
Okay. Eric, this one is for you. What is the best guide or rule of thumb for lithium state of charge using only battery voltage?
So the that's we call open voltage control. So we typically see if you add the 0.0, it's more academic. So I want to, if you charge your capacity like 0.5 C or 0.6 in that range, so we typically see 54.7 volt is 100%, and then if you come down to 51.3 or 4, that's where you see 15 to 25%. So that's the range. But as I just mentioned, so at the end of the curve, at the beginning of the charge and discharge curve, is like you we're doing a little bit moving target. So that's why we set up absorption time, try to use that time and charge up full of the batteries. So with a closed loop, you don't see these issues. With open loop communication, just you lose a little bit accuracy at the beginning of the end of the charge and discharge cycles.
Okay. This one is for Jack, I believe, from Jonah. With grid support, there is a 10 to 30% draw from the grid. How can this be eliminated or reduced?
I'll have to get back to you on that question. I'm not sure. I'm not exactly sure the answer to that question off the top of my head.
Okay. All right.
Yeah.
We have another one here. What must the installers do to integrate the inverter with the Fortress BMS?
We try to let installer do almost as minimum as possible. So as the slide mentioned, so we'll distribute the slide. So in the last slide, I already tell you most of the equipment cable we already provided. So you just need to prepare a single piece of standard communication cable, which is the CAT cable, and then you take two wire out, which is for Modbus RS-485 A and B, and connect to the gateway. So the gateway has a very clear instruction which one is A and B. Once you hook it up, you can use your computer, log into the gateway, start setting up a system. So from what you do physically is very minimum. You don't have to prepare anything. And then on the computer side, you do need to do some setup before you go away.
Okay. Is the gateway available for online monitoring?
Yes.
Yes.
Okay. For generator control, do you provide the necessary L1, L2 voltage presence absence to properly operate the generators without the need for the transfer switch?
So depends on how much power you're trying to pass through on the product with the generator. So you need the external transfer switch if you're trying to do more than 60 amps. So in that case, if you have, say, more than 2 inverters, single phase, then you would need to use the external transfer switch.
Okay. What is the communication protocol?
Let me answer the battery side. So we do Modbus RTU. That's the protocol we use. We can do, but in our eFlex, the BMS platform, we can do Modbus, CAN, MQTT, Bluetooth, Wi-Fi. So there's multiple things. But the current deliverer is doing only CAN and Modbus. So until Q4, you will see the other 3 come on board too.
Okay. Yeah, and in our inverter, the protocol for our inverter platform is ZAN bus, and the gateway is a translator to either CAN bus or Modbus.
Okay. What are the operating and charging temperature ranges for the battery?
I don't have the number on top of my head, so but I can give you it's in our technical spec and installation manual. But I give you a few hard stops. So once your temperature under 32 Fahrenheit, you should never charge the battery. So the battery will start generating the nickel plating effect, will permanently derate your batteries. So 32 is a threshold. Usually, I think I remember it's around about from 45 all the way up to 110. That's the range we said that you can operate the batteries. But there's one thing I want to point out. So it's not a good idea to charge your battery under 32 in any situation.
Okay. In an area where there is no peak shaving or time of day kilowatt hour cost difference, if a customer has an existing 8 kilowatt PV system, would there be any benefit to sizing the battery larger than the PV generation?
If you want to take your customer off grid, that's perfect situation. Again, but that's case by case.
Okay.
Yeah.
Go ahead.
I was to say, if you want to do extended runtime, so for backup applications, yes, it definitely makes sense.
Right.
What is the guaranteed waveform stability under varying loads for the XW Pro?
Okay, that's plus or minus 2%.
Mm.
We basically take in what what the grid gives us, we put out. We don't change it though.
Okay, I think this Eric kind of answered already, but how do the batteries do in the cold? Alaska, minus 50 degrees in the winter. Do the batteries have a heating system?
The battery does not have a heating system. If you have a special application out of the operating temperature range, you need to consult us. We do have a couple of solutions for that. So we see in the market has a lot of the different let's say the cabinet solution, which they provide also either 48 volt or the AC heater in it. So that will help you to keep your system warm enough. But once the battery start operating, it generates a little bit of heat and keep up and down. The most important is once you sit still, doing nothing, and and you want to start it up at under 32 Fahrenheit, then that's the problem happen. So just contact us. We have a solution for that.
Okay, here we have a question from Jose. So at the time of purchase, we must ask the Fortress local representative, are we going to use a Schneider XW? Do they have to do that at the time of purchase?
I think that's open question. So our battery compatible with most of the inverter you see in the market. If you want to use the Schneider, especially we have a closed loop communication, so it's better way we can help you to do the setup in the gateway and so on. All the tests has been performed at the Fortress lab and also at the Schneider, so we kind of very familiar with each other's equipment. If you have a question, then we would like to answer that.
Okay. So we have a question. Can I change the inverter settings over the internet with the Connect Gateway?
Yes, you can. Yeah. Anything you can do locally, you can do remotely with the gateway.
Okay. Dave is asking, what is the largest single setup for Fortress batteries so far?
So for the eVolt, you can stack up at the 12. That's what we see the system is. And then in the eFlex, you can do 15. That's the maximum we allowed as a standard offer. If you want to size up bigger on the eFlex, we can do 50 per customized order.
Okay, we have a question here. Will the battery work on temperatures in Puerto Rico of 105 degrees Fahrenheit?
If it's not under the sun directly, I mean, you have certain ventilation, indoor situation, usually fine. And with the communication with Schneider, we don't see the problem. So the BMS will regulate the production of the battery too. Okay. So that's one of the beauty if you have a closed loop communication. That's just big plus for longevity of the batteries.
All right, we're going to do a couple more because we're running out of time. So Michael is asking, installing Schneider ACS generator control, do I need to remove override the existing generic built-in auto start?
I'm not sure I fully understand the question. Yeah, maybe I can take that question offline because I'm not sure I quite follow that.
Okay. Then we have, will Fortress Power BMS be the same for the XW plus 6048 as it will for the XW Pro?
You work with, okay, let me answer the question quick. You work with the gateway only. If you have a gateway, so that will work. If you don't have a gateway, you cannot build up a communication because the protocol on the inverter and the battery are different. You need a gateway.
Yeah, and there's going to be limited functions, some limited functionality with the XW Plus versus the XW Pro. So I would recommend, yeah, definitely using the XW Pro in this application.
Okay, let's do two more. We have a question. Can Win Series wide range Modbus be used in a grid tie system to avoid injection into the grid?
Wait, what was that question? Can you say that question again?
Sure. Can Win Series wide range Modbus be used in the grid tie system to avoid injection into the grid?
I don't know the answer to that.
I don't know that either. I think we can do some, don't worry about it for the people online. If you have a question we couldn't answer, so the question, we'll take it and then we can get it back to you in the email.
Okay.
I think you're talking about that this is the grid interactive encrypted protocol, those things. I think that's different story.
Okay. And our last question here is, any plans for a 24-volt eFlex module soon for the RV market?
We are looking into it, so there's no detailed timeline yet. So, but we expect that something mid of next year.
Okay. So everybody, we will send everyone the slides from today's presentation, along with the offers for both Schneider and for Fortress Power for our current promotions. So look out for that. And we appreciate everybody's participation, and thank you very much for joining us.
Thank you, everybody.
All right. Thank you, everybody.